In the vast expanse of our solar system, Saturn's moon Iapetus stands out as a celestial enigma. Discovered in 1671 by the astronomer Giovanni Domenico Cassini, Iapetus has captivated the imagination of scientists and stargazers alike. Its most striking feature is its dramatic two-toned appearance, a celestial dance of light and shadow. Imagine a world where one side basks in perpetual sunlight, its surface as bright as freshly fallen snow. This is the trailing hemisphere of Iapetus. Now picture the other side, shrouded in an inky blackness so profound that it reflects very little light. This is Cassini Reggio, the leading hemisphere of Iapetus, named after its discoverer. The stark contrast between these two hemispheres is a sight to behold. The dark material that blankets Cassini Reggio has been a subject of much debate and speculation. Some scientists believe that it originates from within Iapetus, possibly through volcanic eruptions or outgassing from its interior. Others speculate that it is composed of dust and debris captured from other moons, or even from beyond the Saturnian system. What we do know is that this dark material is incredibly fine-grained and absorbs a significant amount of sunlight, giving Cassini Reggio its characteristically low albedo. The bright trailing hemisphere, on the other hand, is thought to be covered in ice. This ice is likely a mixture of water ice and other frozen volatiles, such as ammonia and methane. The high reflectivity of this icy surface is what makes the trailing hemisphere appear so bright in contrast to the dark Cassini Reggio. As if its dual-toned appearance wasn't intriguing enough, Iapetus harbors another mystery, a massive equatorial ridge that encircles the moon like a raised belt. This ridge, which can soar to heights of up to 20 kilometers, is unlike anything else found in our solar system. The ridge's origin is a matter of ongoing debate among scientists. Some theorize that it formed early in Iapetus's history when the moon was still hot and spinning rapidly. As Iapetus cooled and slowed down, this equatorial bulge may have solidified, leaving behind the ridge we see today. Other scientists propose that the ridge is the result of external forces. One intriguing hypothesis suggests that it formed from the accretion of material from a ring system that once encircled Iapetus. Imagine a time when Iapetus was surrounded by a thin disk of dust and ice. As this material gradually spiraled inward, it could have piled up along the equator, eventually forming the ridge. Adding to the enigma, the ridge is not uniform in height or width. It varies considerably along its length, with some sections towering high above the surrounding plains, while others are more subdued. This suggests that the processes that formed the ridge were complex and may have varied over time. Our understanding of Iapetus took a giant leap forward with the arrival of the Cassini spacecraft at Saturn in 2004. Named after the moon's discoverer, the Cassini mission provided us with our first close-up views of Iapetus, revealing its surface in unprecedented detail. Cassini's cameras captured stunning images of Iapetus's two-tone surface, allowing scientists to study the boundary between Cassini Reggio and the bright trailing hemisphere in detail. These images showed that the transition between the two regions is surprisingly sharp, suggesting that something is preventing the dark material from spreading to the trailing hemisphere. The spacecraft also provided valuable data on Iapetus's composition, temperature, and gravity field. This information has helped scientists to refine their theories about the moon's formation and evolution. For instance, Cassini's observations suggest that Iapetus is primarily composed of ice with a small rocky core. Despite the wealth of information gathered by Cassini, Iapetus continues to be a source of fascination and mystery. The exact origin of the dark material in Cassini Reggio remains elusive, as does the mechanism that keeps it confined to one hemisphere. The equatorial ridge, too, continues to puzzle scientists. Its unique morphology and global extent suggest a complex and intriguing history. Further study is needed to determine whether it formed from internal or external processes. Iapetus stands as a testament to the vastness and diversity of our solar system. It is a world of stark contrasts where light and darkness collide, and where a giant ridge encircles the equator like a celestial scar. As we continue to explore our cosmic neighborhood, Iapetus serves as a reminder that even in the 21st century there are still mysteries out there waiting to be unraveled.